So, sorry about the mess. My name is Trina Jo Bradley. I'm the executive director of the Rocky Mountain Front Ranchlands Group in Montana. Welcome to the Soil Health and Nutrition Management webinar. I had some really cool slides to show you of my cows, but I guess I'm not going to. So Rocky Mountain Front Ranchlands Group is a producer-led group that was formed in 2021 with the goal of keeping ranchers and farmers on the land. We serve the Rocky Mountain Front from the Canadian border to south of Augusta, if you're familiar with Montana. Our mission, we strive to preserve family ranches, farms, and rural communities by carrying on the traditional conservation practices that have supported and protected our landscape for the last 100 years. We support profitable ranching, farming, and other traditional livelihoods to sustain the open space nature of our land for generations to come, to benefit both egg producers and Montana's numerous wildlife species. It'll be much easier with my slides. So I focus most of my energy on conflict prevention, mostly with grizzly bears and wolves, but through a grant through National Fish and Wildlife Federation and a ton of help from Western Landowners Alliance, we were able to hire Lori Rosenberger as our outreach coordinator. And I will let her know, I will let her tell you what she does in a minute. Contact me anytime if you have questions or concerns. Linda, can you put my website in the chat since my eyes aren't working?
Sure.
And then I will hand it over to you to introduce Western Landowners Alliance.
Yeah, I will. I'll drop some links in the chat here as soon as I'm done talking, so I don't multitask and give us another technical difficulty. Welcome, everybody. I'm Linda Poole. I'm the Working Lands Director with the Western Landowners Alliance. And if you don't know WLA, we are a West-wide organization with around 14,000 members. Membership is free. And the work that we do is all around creating whole and healthy landscapes, communities, and economies across the West. And we have various programs that we advance in different ways. If you're from the Rocky Mountain Front, like Trina and Lori, you might know Western Landowners Alliance as being helpful through the Working Wild Challenge, where we deal with predation issues, big game issues, finding ways to have agriculture and conservation come together in ways that are profitable, sustainable, and equitable to the people on the land who are stewards. Another part of what we do is the Forest and Range program that I work on. And through that program, we've had the honor and the privilege of working with groups like the Rocky Mountain Front Ranchlands Group, locally based groups who are bringing together a collaboration of the landowners on the land, putting that in front of the stewardship of a landscape. And so we are really thrilled to have received a grant from the National Fish and Wildlife Foundation that's allowing us to have Lori on staff and work with Trina on this type of work. I want to mention just two quick things about WLA. We just completed a landowner investment survey of people and ranches across the West. And we asked some questions about who's putting in and how much of the resources that a landowner has goes into the stewardship of their land. And not all of that is compensated. Some of it is. It's a wonderful study. And I will drop a link in the chat there so that you can look into that. And another thing that we have going right now, Danny Howlett, who's on the call with us here, she is leading up a peer-to-peer networking group of ranch managers and landowners, owners/managers of ranches in the West to peer network around ranch management issues such as access and hunting and grazing management and succession and all the things that we care about and deal with on the ground. So I will put that link in there too. Just to remind you, in case you jumped in just a little late, some of you are, when you're coming into the room, your name is Danny Howlett. Be sure to go to the three little dots in the corner of your tile, and you can rename yourself with your real name. We would be really happy if you jump over into the chat and introduce yourself and tell us where you're from, and use that chat feature at any point to type in any questions that you have. The second hour of this whole presentation will be questions and answers, and we'd love to be able to interact with you there. So with that, I would love for Lori, who's our person on the ground there doing the work, to tell us a little bit about her job, and the rest of the webinar goes forward with that.
Hello, I'm Lori Rosenberger. I work for WLA, and I work with Rocky Mountain Front Ranchlands Group. I'm here as the boots on the ground between the producers and all of the programs available. I help them make management plans and incorporate any programs into their production that they want to apply for, help them get funded, and I am always available if anybody wants to do a management plan. But I met Donnie in Dillon, Montana. He was doing a workshop, and I wanted to share all of his information with all of you. So thanks, Donnie, for coming today.
Yeah, happy to be here.
Okay.
So Donnie, there. Yeah.
My computer is glitching like crazy, so bear with me. So now we're gonna get to the part that everybody wants to see. So Donnie, if you want to get your screen set up, I will just introduce you real quick. So Donnie Englehardt is an experienced agricultural consultant with a deep-rooted commitment to advancing soil health, plant vitality, livestock well-being, and water quality. With a diverse background spanning regenerative land management and sustainable farming systems, he brings an integrative perspective to every operation, large or small. Driven by the belief that nutrient-dense food is the foundation of health for both animals and humans, Donnie works to connect the dots across the entire ag ecosystem. From improving soil biology and crop resistance to enhancing forage quality and animal performance, his approach is grounded by field experience and centered on long-term ecological and economic viability. Whether consulting with producers, land stewards, or food system stakeholders, Donnie is dedicated to helping clients build healthier, more productive systems that deliver real nutrition from the ground up. After Donnie's presentation, we will have plenty of time for questions, so please be ready to start asking. If you don't want to ask a question live, you can always put it in the chat.
Okay, can you guys see everything okay?
It looks great.
Okay, all right. So first of all, thanks for the invite and welcome to everybody who's here. And I guess we're gonna kind of dive right in. I'm gonna probably have questions, like they said, at the end of everything. So if you're listening and have some questions, take some notes, and we'll get to those towards the end. So with that, I like to usually start everything off with a prayer. So if you don't mind, we'll say a quick prayer real quick. Heavenly Father, we thank you for the gift of the earth beneath our feet, for the soil that sustains life, nourishes our crops, and supports every living thing. From the smallest seed to the tallest tree, your wisdom is revealed in the ground you have entrusted to our care. Grant us insight to make decisions that protect and restore the health of the earth. May our work reflect gratitude, responsibility, and hope for the future. Bless this meeting, our efforts, and the land we serve. Amen. Okay, so let's get started. We got a lot to cover, and I'm kind of excited to hear some questions at the end, so please engage at the end. So this is what I have: healthy systems and profitable farms. We're going to talk about a lot of different things, and we can get into the weeds at the end as much as you want. So this, I want you to know that this whole presentation is all about you guys. I'm not here to sell you anything. There's no sales pitch. This is about giving you guys wisdom today. And when you hear something and think about it and learn about it, it becomes knowledge. And when you take that knowledge and replicate it and practice it over and over, now your knowledge becomes valuable, and value will make us all successful. So let's start jumping in here. Okay, so first, a farmer's or rancher's productive capacity is directly related to the health of the soil. So when we think about all the assets that we have on our farms and ranches, what should be our largest asset in our farm or ranch? Should be soil, correct? So now this talk is really going to be based on solving problems, not giving you a reaction to a symptom to a problem, which is a lot of what mainstream agriculture seems like to me in a lot of scenarios, in a lot of cases. Or, telling you something you can use that really isn't going to fix anything, like a Band-Aid, but it's just going to get you through the next year and the next year and the next year so they can sell you something the next year and the next year. We can cut down a lot on these situations with what we purchase for inputs, and we're going to kind of dive into a little bit of that and how to do that. And a lot of this is going to be based on my experiences, which I'll kind of go over some of those and how I became to where I am today. But first of all, with this slide, what is healthy? Like, how do we define healthy? Like, what is that? Especially when we talk about soil. So healthy to me is without disease or impairment. So anything along those lines of disease, impairment, tied up nutrients, insects, things like that. When we have those in our soils, it's not healthy. So I like to call healthy without disease or impairment. All right. So again, going back to the largest asset in our soil is our soil, but what do you actually know about the largest asset in your operation? When it really comes down to it, are you the one making the decisions to do the things on your farm and ranch and soils, or is somebody else making those decisions? And some people really get this and focus first on below ground management instead of above ground management. And some people still rely on their inputs providers, like I said, to make all the decisions. In the second part of this, the best fertilizer for any soil is the footsteps of the farmer. This cannot be done from the seat of a pickup or the cab of a tractor. So if there's something I want you to take away or get from this today is to educate yourself on anything you might have questions on. And pretty soon I'm going to just go through some of how I got started in this and why and where questions develop for me. Everything I'm going to discuss is really my infield experiences, and a lot of those infield experiences are stemmed from the work and the knowledge of William Albrecht, Kerry Reams, Dan Scow, Arden Anderson, Charles Walters, Maynard Murray, and others to name a few. Just a couple that I've worked with a little bit too. Tom Dykstra and Glenn Rabenberg also have some really good things to say. I would encourage you all to educate yourselves with the teachings of these individuals, and I can tell you that it works. It really works. So we're going to move into moments and meanings for me. So like I said, going back, I'm going to kind of tell you a little bit about me first. A little bit about me. I grew up in Nebraska, corn and soybean country, and I had many opportunities to be on the soil, from working with seed corn production, also as field manager for soybean and wheat production facility called Remington Seeds. Also being a water quality specialist for groundwater in high nitrogen use areas. An agronomist also for Cargill in the Midwest. And I had my own soil health business that I still have. And now a soil health specialist for Rocky Mountain Supply. And the reason I'm with Rocky Mountain Supply, they kind of seen the need for someone to have the conversations about regenerative ag and some different pushes forward that a lot of traditional agronomists can't really speak to or have those conversations very well. So they seen a need that, hey, we got some farmers around here in this area that are wanting to know more about how can nature provide services for free for us in these fields. And that's been fun. And there's actually a lot more people interested in that direction than I thought there would be in this area. And it's just been a lot of fun to learn and educate, and just been a good thing. So going to this slide here, moments and meanings. I was, during all my traveling and all of my being in the fields in different states throughout the whole U.S., I seen things that universities said you couldn't do, or some people would say let's just take this one for example. Why do some producers need a pound or a pound 0.2 of nitrogen per bushel of corn to get 200 bushel corn? So a lot of it is inputs facilities saying you need 1 to 1.2 pounds of nitrogen per bushel of grain to get to that bushel of corn that you want to get to. So in that, I was talking to a lot of different producers and seeing a lot of different fields. Just give you a case study where we applied 40 units of nitrogen onto a cornfield, and we were still getting 200 plus bushel corn in areas that we were only applying 0.2 pounds of nitrogen per bushel. So back in my early days, that was like, how is that happening? Like, why? That's not what I've heard needs to happen. So that was a question. Why can some growers raise 120 bushel soybeans on very little phosphorus, potassium, and some needs a lot and can only get 70 bushel? Those were just a couple things. Why does alfalfa not fertilized yield the same as spending 60 to 70 bucks an acre on fertilizer? Why does some seed fields have better germ and appearance than others? This went back to my seed production days, and you'd have the same varieties grown right across the road from each other that would have a 2% better germ. And there was a lot less seed coat splits on soybeans, a lot less disease in wheat seed. And that was where I've seen some of that. Why do we have the weed issues we do? We're going to go into weeds, and I want you to have an open mind when we talk about a lot of the stuff we're going to talk about today. Why do certain fields have problems with nitrates? So we've got a producer here right next to Dylan that typically always has high nitrates in its forage production. And we've come up with a reason and a couple of reasons why we have high nitrates in our forage production. Why are insects consuming certain areas of the fields? Seen that a lot as I was traveling throughout the U.S. Insects were a big deal, and we just wanted to go spray insecticides and take care of the problem. And we're going to go into why there's a better way. What are the components of nutrient tie-ups? Another question. Or what is any fertilizer source better than another for soil life and biology? We'll talk a little bit about that too. But those were just some of my questions. Now, I know you guys probably have your own questions, and you've seen things that just don't make sense to what people tell you that, that this is, you need to fertilize more, you need to fertilize this, and we're going to kind of get into that. But use those questions you have to do research on your own and learn. So I'm going to give you a few books that I've read that are extremely good to read, that a lot of this stuff will make sense. Just really educate yourself. Do your own research. There are a lot of companies out there that'll make money off you if you don't know. So they will sell you stuff that reacts to symptoms, when really Mother Nature has it all laid out. We just have to understand it. Here's a few more books. I'm going to give you a little bit of time. If you want to write those down, that's fine. I don't know if we're going to share this presentation or not, but these 3 books also are some really good ones. The one in the middle, The Farmer Wants to Know, that's one that I read. I think it was published in like 1979. That was one that really got me down this path, and then branched out beyond that. And these are just a few of the books that I've read that I would recommend. There's a lot more, but not going to just sit here and throw a whole bunch of books at you, but here's 6 that I feel have made a big difference. When Weeds Talk, the one on the right there, that book is giving the environment in which weeds like to grow. Weeds are growing because they don't enjoy the 5 things that are most important for your food crop, which we're going to go over those 5 things. Weeds do not like available calcium, available phosphorus. They don't like carbon. They don't like oxygen, and they don't like aerobic soil microbes. So there's some patterns that I'm going to see if this works. I know this is kind of small. I'm going to try to zoom in here real quick. So you can see right here that on the top, on the upper right-hand side, you have the calcium, the P2O5, the K2O, the mag, the manganese. There's a lot more. I didn't put the other page of this, but there's a lot of other nutrients that you can look at to see what a weed likes to thrive in. So as you're just kind of looking through this, and I would say that most all 25 pages of all these weeds are very similar. You look at calcium and you see that a weed likes a very low to very low calcium environment, and that's available calcium. P2O5. So that's the only phosphorus that can be taken into the plant. And we're going to go into what the O5 stands for and why and how that's important. The very low phosphorus levels. Weeds like a high potassium environment. Weeds also like a very high magnesium environment. And we'll just scroll down here to one that you guys are probably familiar with, but dandelions. It's like 4th or 5th one from the bottom, 5th one from the bottom, dandelions. So how many of us probably see dandelions in our yards or in our fields, in our pastures, wherever? That weed is there to tell you something. And that weed is there because that dandelion's looking for calcium, available calcium. And that is probably one of the most missed things in traditional agronomy or agronomics that we apply for inputs. And we'll kind of go into that a little bit more too. But again, this is from the When Weeds Talk book. So let me jump back to that one. So the one on the right, When Weeds Talk, that's a page out of that book. And when you really want to understand weeds and what environment they thrive in or don't thrive in, it's a great book. So all of them are great. I just encourage you to look into those, educate yourself. Really good reads. Okay, so now let's jump into what do we call, I guess, first of all, on the right, you have an aggregated soil. On the left, you have a compacted soil. Now, we all know what an aggregated soil looks like or what it should look like. But a compaction soil, which is on the left, a lot of times people just think, well, it's compacted. I've been driving over it a bunch. And I've just got these compaction areas where I'm always, running through it with tractors or trucks or whatever. Really, compaction is a fertility imbalance. I have fields all over here around Dillon that are compacted soils. And it's not because the machinery is doing that. It is because of our poor soil structure that we have in a lot of these fields around here. So looking at the one on the right, you can see there's air, there's water, there's mineral, there's soil organic matter. And you can look on the left and say, okay, well, our soil structure is imbalanced. And that is really what causes a lot of our compaction. And I will tell you, once we get into a couple more slides, why we're seeing so much compaction or how our soils are poorly structured. And a lot of it has to do with high magnesium, but there's more to it. Anyway, we'll jump ahead. So again, compacted on the right, poorly drained in the middle, and now you have the ideal on the left. Compacted, right? Lots of mineral, poorly drained, lots of water. Ideal, we're at about that half and half for air and water. And that is something we are going to talk about a lot, is air and water. If we can't breathe, what happens to us? If soil can't breathe, it's the same thing. Compaction is really a fertility imbalance. And one question, I guess, that, if you guys think about is when you look at a soil test is how do you measure air in the soil? What's a way to measure that when you get a soil test? And really, there's nothing on that soil test. I mean, there is if you understand a lot of the soil makeups and the compositions of things, you'll see it. But I use a penetrometer to measure soil or air in the soil, and everywhere I go, that's always with me. And I'm going to talk about a few other things that I always carry with me that I'm measuring whenever I'm out in the field. But air is a big one. So when you get your soil to inhale and exhale, microbes are happy. Lots of minerals need to be hooked to oxygen to become available to the plant, such as, if you go back to our picture here of P2O5 up there at the top. What does the P2O5 stand for? So you need a handful of oxygen, right, in order for that plant to have available phosphorus. So that is something that I'm going to drive home here today. Okay, so suppose we were going to cover these top 5 ingredients to create the environment for living soil. Now, these are just the ingredients. This isn't what if you achieve this and, well, shoot, Donnie said, if I achieve this, everything's all good. You still got some work to do. You still got to make sure things are in balance through your soil. And by that, I mean base saturations and things like that in your soil test. So top 5 ingredients. Number 1, available calcium is something I always look at first or second on a soil test, because I have to know where we're at. Are we short? Or are we not? Calcium is the most neglected nutrient in those fertilizer programs, which I mentioned before. To me, this is the primary cause of poor soil structure in our area down here by Dillon, is that calcium never gets talked about. If a fertilizer recommendation gets put out by a company, you will see hardly ever a calcium recommendation on any given recommendation from any agronomist in the area. So that is number 1 that I feel like is extremely important. Number 2, available phosphorus, which we went through a little bit of that. And, the other thing too, I'm just going to back up here on calcium. When you look at a soil test and you see the number, right? That's the largest number on our soil test. Like, it is the heaviest, it's the biggest, most volume. And a lot of us just always think we have enough calcium, and it may not be available. So there is a issue with soil testing, in my opinion, when it comes to calcium, that it really does not have an accurate way of showing us available calcium. Now, when we talk about available phosphorus, the plant can only take in the P2O5 phosphorus, so it needs oxygen. A tissue test is really the best way for me to know if calcium is getting into the plant also. So my soil test could say I got all kinds of calcium out there. And then my plant tissue test comes back and it's not where I need it to be. And we're going to go over a couple of those numbers and where they need to be on a tissue test, sap test, petiole test, whatever you guys do. This is an important one. These two, like to call calcium the mom, phosphorus the dad. The mom always keeps everybody in check with calcium. Phosphorus the dad kind of regulates. So the next thing, so the number 3 is carbon. And you'll hear a lot about how do I add carbon into my soils and what's the best way. And I mean, there's a lot of ways that people think carbon is the best way. And compost manures, or, a big one. People think carbon is, you're putting a lot of carbon in. In my experiences, from everything that I've done, cover crops are probably the quickest way and the most effective way to feed microbes and to release CO2. And if you really want to understand that, study organic chemistry, and you'll see how all of that relates and why it works so well. We're going to go into cover crops here in just a little bit as well. But number 4 is oxygen, which we talked about that. If your soil can't breathe, then nothing's living, just like us. You need that soil to inhale and exhale. So when a high pressure system moves in, it's got heavy sinking air, and that air needs to get down into the soil. All of those microbes need to respirate and release CO2. So the inhale, the exhale. And that is something that a lot of our soils down here by Dillon, just we don't have a lot of air in our soils, and that's something we're working on. And then the beneficial aerobic soil microbes. That's where everything is going to happen, is if they're partying in the soil. So just keep that in mind. Okay, we're going to move real quick to what is the dry matter of a plant made of? Okay, so we all grow plants, right? So what is it made of? Like, how do we know what to use for inputs if we don't know what our dry matter of a plant is made of? Okay, so I'm just going to run through these quick, and then we'll kind of discuss them a little bit. If you have more questions on this, that's fine. So 45% and maybe 47, 48% carbon, 45% kind of being the low, 42% oxygen, and 6% hydrogen. So now you can see how much percentage of the dry matter of a plant is just made up of those three. How much money do we spend on carbon, oxygen, and hydrogen when that's what makes up our plants? Typically, we want to go throw nitrogen out, or phosphorus, or sulfur, or zincs, or potassiums, or whatever, because that's what the agronomist or industrial America, or I guess academia, says that we need to do. There's also 1 to 5% other minerals. There's also 1 to 2% nitrogen. So if we look at our nitrogen bill, a lot of times it's probably extremely large in some situations and operations, but only 1 to 2% of our dry matter of our plant is nitrogen. Kind of gets you to thinking about maybe what's more important. And I guess, we all know how plants convert carbon dioxide and water into glucose, oxygen, serving as food for the plant. That's the process that we want to enhance. And when we have healthy soils, and we have soil that can breathe, soil that has good carbon, soil that has hydrogen, and we do need other minerals and nitrogen, but to a very low percentage. Okay, so moving on here to, we must focus on the livestock below our feet first before we've earned the right to do anything above ground. We're going to talk about these 5 most influential soil biology factors that I've kind of ran across that made the biggest differences on soil tests and just plant tissue tests, and just yields in general, in creating just a better structured soil. So number 1, microbial biodiversity. So if you look at the picture on the left, that's just a grower that we have here. There was just an alfalfa grass guy for a long time, still is on some of his fields, but we're trying to show him that the diversity below ground is actually feeding and creating more carbon than anything else that he's ever tried or anything else we've done. So you can look at that mix and you can see the grasses, you can see the clovers, you can see the alfalfas, you can see the vetches. This is actually a 7-way cover crop blend. And he's using it for a hay crop / graze. Depends on what he needs, but he can do either with this mix. And we're really short, and we might cover this later, but we're really short in selenium around here, and so selenium is a big part of our mineral plans in this area. And the only way that I know that I've seen so far in this area is to add vetches into a cover crop mix or into the system somehow. That is where I see the most benefit in selenium, getting into that forage analysis or hay analysis that we get back after we probe bales or do tissue tests. So vetches are a big one for selenium, and there's a lot of other things I could discuss with you on why this cover crop is so good. But for this area, we've seen just protein levels increase. We've seen RFEs and TDNs increase just by switching from an alfalfa grass to this cover mix. Now, if a plant is looking for carbon or oxygen and can't find it, it's going to take nitrogen for a substitute, and that causes some issues. If a plant can't find calcium, it'll take up potassium for a substitute, and that creates issues. So nitrogen and potassium will grow a wonderful, probably GMO crop, genetically modified crop. Nitrogen and potassium are loved by weeds, and they're also, they love to create diseases. And therefore you also have a less healthy plant, which also attracts insects. So number one, microbiodiversity. Number two, mycorrhizal fungi presence and activity. So in this area, which I'm sure you guys are probably the same way wherever you're at if you're in the state, but mycorrhizal is tough because of our short growing season and our cooler temps. And we have a lot of bacteria in a lot of places, but we really need to find some beneficial fungus that's around here. And when you start increasing the calcium, the phosphorus, the oxygen, hydrogen, beneficial microbes, all of that, you start to see more of this mycorrhizal fungi, as well as with these diverse cover crop mixes. I'm seeing more when I'm digging roots, when I'm in these cover situations. So just wanted to pass that along. Root exudates, living roots, and we've talked about that a lot, but it's a lot of where our sugars come from. And once we have high sugars in a lot of these plants, we are growing a nutrient-dense crop with good mineral content, and those root exudates are a big part of that. And then there's fungal to bacterial balance. Again, we don't want to be all bacteria. We got to have some fungal systems in our soils to be balanced. And you can use the PFLA test, which is a fatty acid test. I think it's Regen Ag Labs that is probably the best one that I've used that shows you the fungal to bacteria balance ratios. And but also just digging in the soils, you're going to be able to see a lot of things changing, and those tests will confirm that you're seeing some fungal to bacteria ratios getting better if you do these things and start improving. Soil to food web structure. So there's a predator versus prey balance that kind of need to be in there also. All right, so I'm going to jump to just a lot of the things that I use when I'm out talking to farmers, whether it be for the first time or been with them for 15 years. We're always going to go out in the field. We're always going to go look at the soil and the plants if possible. And we're going to do some tests right then and there, just because we want to know. What's changing? I want to know. So up at the top, that's a penetrometer. Again, that is going to be a big key item when you're out looking for, is oxygen able and air able to get into these soils. So if surface tension on these penetrometers is over 200 psi, you're not getting the air in the soil that you need. Therefore, you're suffocating living organisms that need that air and oxygen to breathe. Weather matters. I was telling you before, the high pressure fronts heavy sinking air in soil containing nitrogen, oxygen, CO2. It's what the microbes need to respirate. So again, just reiterating the fact that we need that soil to breathe. And it's one of the most limiting factors here around the Dillon area that I've seen. If your soil is resistant to area or to air, you're suffocating the microbes. If below 100 psi, there's nothing in the soil to hold nutrients for those microbes. So if you have a really sandy soil, a really light CEC soil structure, you're gonna have to do some foliar feeding at the time during when the crop needs it, not just, which in fact should be done all the time anyway, but especially on soils like this, if ever you're putting anything through the pivot or sprayer, right time is crucial on these really light soil structures that you can just lose nutrients very quickly. So carbon and nitrogen ratio, and we'll talk a little bit more about this too, has a direct correlation to microbial feeding. What I've found in our soil tests and in our soils around here, 16:1, things are just starting to happen with microbial feedings and microbial activity. When you get to that 25:1, now you're there. 30:1 would be amazing, but anywhere from 16 to 25, things are starting to work, and that's a good position to be in. Now, anything lower than that 16:1, your microbes are going to have a tough time getting anything to feed off of. So EC meter, that's the second picture down on the bottom. If an EC reads over a 1, microbes will not do anything for you. It's too high salts, and they're getting shocked because of the high electrical conductivity that is in your soils. Too high salt, sodium, so 0.3 and 0.7 is what microbes need. So you want to be in that range when you're out there with an EC meter. Again, some of these lower areas that I have around here, around river bottoms, we have high sulfurs and high salt contents, and we need to know where those are at in order to know what to do. So if ECs are low, check the sulfur. Salts, organic salts, are created by the microbes. They never burn, and they'll work for you. Inorganic sodium chlorides, kind of got to watch out for those salts because they're not organic salts, and those two work differently. So organic salt's good. Sodium chlorides, inorganic salts, you can still use them. You just have to be very careful on why and when. So that's going to be feeding the soil microbiome, bacteria, fungi. And when you think about salts, we think about like free choice in cattle or animals. You know, what is the one free choice block that we always put out there for cows? Usually a salt block, right? Okay. So what does salt do and why is it important? Well, it connects the feed stuff and the minerals in the rumen to the microbiome. So it's related to the soil where it's feeding the microbiome and the bacteria and the fungi in the soil also. But a cow knows kind of when to quit eating salt, whereas if you flood it with salts in the soil, you're going to get some bad reaction there. again, if they are getting shock from salt and you have those high salts, you need respiration, and you just need to put some carbon and calcium in the soil. And we can discuss some of that in questions and answers if you want. Another tool that I use is the water infiltration kit. It's really good for when you know there's an issue, but maybe the farmer doesn't know there's an issue. You can go out there and do this test with them and say, hey, let's do this water infiltration kit. Let's see how long it takes for your ground to absorb an inch of water. And you let me know if you think that's concerning or not. So I like to have that test kit with me all the time, just because I don't know when I'm going to run into those situations. Refractometer, this is a big one. I use this one a lot as well. In fact, I don't know how many garlic presses I've broke and how many other things I've gone through. I don't know if you guys, I don't have one with me, I guess, but I have a vice grip with two little plates welded onto them, and that is how I get the juice out of the plants, because garlic presses just don't work for me anymore. So refractometer is obviously testing the Brix levels, sugar levels in your plants. And it's extremely important to know that, especially if you're doing any changes in a fertility program or a soil health program or a cover crop program or anything, where were you on sugar levels before any of those changes? And then now where are you? It will help you track changes. Most programs in the fertilizer industry will not raise Brix levels. Just so you know, 4, 5, 6 Brix is not good. What do fungal diseases like? So typically a warm, wet, low sugar environment and a negative charged environment. Root exudated sugar, water, and minerals. What do insects like? An unhealthy plant. Listen to some of, I mentioned Tom Dykstra, and we're going to pull up a slide of his here in just a little bit. But very, very knowledgeable on insects and why insects are in fields and why they're not in some. But Tom Dykstra talks about this a lot, and he will explain this more in depth if you guys do some educating on your own. And a cow, just so you know too, can tell a difference between a 0.1 sugar level difference in a plant. So if you don't think sugar levels are important or don't think they're as important, treat an area, don't treat an area. And with that area you're treating, do what you can to raise Brix levels and let the cows go free choice on where you want them to graze on that field. And they'll tell you what they like more and what they're going to gravitate towards more. So again, really important. The refractometer is a big tool for me. I use them a lot. Okay, so now we're going to go to deficiencies, right? So why do we see deficiencies? A lot of times your agronomist will say you're low in nitrogen, you're low in phosphorus, you're low in potassium. So add more, right? If you're low, you add more. Do they ever talk to you about the antagonistic effects from nutrients in excess? So what this little chart is showing you up top is primary nutrients, secondary nutrients. All those nutrients on the top side of that are nutrients in excess. The ones on the bottom are what it's antagonizing. So let's just move to calcium for an example on the top. Right below that arrow, it says B, Mag, and P. So if I have really high calcium levels, I'm now affecting my boron levels, my magnesium levels, and my phosphorus levels. Same with magnesium, which is one of the big issues around here, is my high magnesiums are tying up my calcium and my potassium. So when you look at a soil test and you say, oh, my potassium's not there, my calcium's not there. Just picking on mag for this example, like, well, let's not just apply more potassium, but let's see why our potassium's not available. And a lot of times in my area, mag is the culprit. And again, I don't want to treat the symptom by just putting on more calcium and potassium. I want to fix the problem. And I want to balance things out to where my mag doesn't take such a big spot on our base saturation. So same with all these nutrients. Too much of anything in the absence of balance can and will create limiting factors. And it's extremely true. Not all deficiencies are caused by a lack of nutrients. So just keep that in mind. We're going to go into soil tests here in just a second. But when you're looking at soil tests and you see lows and highs, and just because it's high doesn't mean it's good. It might actually be too high, and it might be causing you problems down the road. So keep looking at that as time goes on. This is going to be an example of that. So this is a soil test, one that we have just east of town here, not very far, that's kind of down on a river bottom. And when you look at a soil test, I think probably the first thing that you want to look at is pH. So is my pH in the road ditches, which means am I outside of a 6.4, 6.5 to a 6.8? Because that's where you need to be. Am I quite a ways away from that? Or am I in that 6.4 to 6.8 range where you need to be? So a lot of producers I've noticed make a lot of decisions off of just pH alone. A lot of times if you're in a low pH and you want to raise pH, you apply calcium, right? Well, up in the Big Hole area of where I'm at, which is about an hour away from Dillon, we have 5.6 pHs, 5.5 pHs, 5.4 pHs. And the problem is everybody just thinks, okay, well, let's just go put calcium out. That'll fix our issue, which honestly doesn't even happen up there. It's mostly all nitrogen, but they need to be applying calcium up there. But you got to make sure that your aluminum in those low pH situations, your aluminum is not too high, because if your aluminum is too high, your calcium's not going to work. So then you have to bring silica to the table to get the calcium to work alongside with the high aluminum. So just because you have a low pH doesn't always mean you just go apply calcium. You want to make sure that that calcium is going to be well spent before you go spend it. The second thing I usually look at is calcium. And you can look on this soil test, and hopefully y'all can read this, but we're over 18,000 parts per million in calcium. Here's one of the biggest problems that I see with traditional agriculture and agronomy and just the way we do things in prescriptive mode. A lot of times we look at that number and it looks high on the chart, right? Your interpretation says, well, my calcium's really high. I don't need to worry about that. Again, like I was telling you before, don't get fooled off of this number. You really need to look at a tissue test to see what your plant is actually getting for calcium. Now, if in the reason you are short in calcium, then that number, first of all, calcium determines total volume of yield and should be applied to meet a minimum of 300 to 350 pounds per CEC, not pH. So we're always taught that, well, if our pH is low, we add calcium. So what happens if our pH is high? Is anybody going to ever recommend calcium based on pH? Probably not, because pH is high. We don't want to raise pH. And that's not the way we should think. Really, the way we should be thinking is that on a soil test, and again, this isn't the number that you should look at. I would look at the tissue tests more than I would look at the soil test. That calcium number needs to correlate to the CEC of the soil, not the pH. So in those high pH situations, calcium's never a recommendation because apparently we have plenty of calcium out there, but that doesn't mean it's available. Potassium, when it's really high, it hangs on to water. Water dilutes the sugar content of the plant. So big manure guys, watch out for high potassium levels because it's kind of, I had a conversation with a guy a while back, and what's another name for manure? Crap, poop, or just shit. So with that, it is not high in calcium. It's not high in phosphorus. And those are some of the biggest things that we need to be applying in a healthy environment or a living soil environment. Potassium hangs on to water, like I said, and it dilutes the sugar content of the plant. It kind of creates a squirty manure coming out of the cow, and you don't want that. Carbon and oxygen deficiency is most of our problems in this area. And again, you can't see that really on these soil tests like this. So just going back to the carbon oxygen thing, extremely important. You're probably not going to see any of this on your tests, but you can look at the dry matter weight of a plant too, and you can see how imbalanced you are in what you're focusing on. Third, base saturation. So down at the bottom right corner, that's your base saturation percentages. Balance it's just kind of an indicator for me. Everything else on the soil test is not really that helpful, honestly. A lot of it is just irrelevant when it comes to what the plant can actually get, in my opinion, and what I've seen. So I focus more on the tissue test than I do on most anything else. But base saturation is good because in this situation, it looks like we have 0 hydrogen. Obviously, our pH is at a 8.1. Calcium is high. It's not in that range that we need it to be. Magnesium, 15 to 20. Nope, we're at a 9.9. Potassium, 1.1. So these are the things that I look for. Top 3 things: 1, pH; 2, calcium; and 3, I'm going to look at the base saturation. And that's a balance indicator for me on those 3 things. So one thing I want to point out too here is I'm going to go through a couple different slides. There's 2 of them right here. There's 2 soil tests. One is this first one. You can see what the recommendation is. If you look at first crop choice at the very top in the green, the dark green, first crop choice, second crop choice. Okay, if I send this to a lab and they say, okay, let's put on the NPK, whatever's, to meet that 2 ton to the acre or 3 ton to the acre, that is where I see the problem lying when we're recommending the things that aren't actually fixing the problems. So in 2 ton alfalfa grass or just grass mixture is what this one is. They're just recommending nitrogen 40 units and P2O5 19 and a little iron and a little copper. And so that's when you look at fixing or trying to treat symptoms versus actually finding out what the problems are. In this situation, I went through a couple different things here. So one is, if you look at the magnesium numbers, as I bounce back and forth between these 2 slides, magnesium's on the left-hand side down closer to the bottom, but right next to calcium and copper. So in a 2-month span, I just want you to see the magnesium change and the difference of what that made and how that looks on a soil test. So we went from a 1249 parts per million all the way to a 749 or 794 parts per million. Now, we can discuss what we did to this field later. Otherwise, we'll get too far in the weeds with other stuff. But in the Q&A session, just bring this back up, somebody, if you have questions on this.
Hey,
So
real quickly,
yep,
Donnie, we
yeah,
are in the second hour, so I don't know how
okay.
you want to fit the Q&A in.
So,
We're losing a few folks. Yeah.
okay, so I got to regroup here. All right, so looks like this is a tissue test. I just want you guys to see that and the progress that we made just on a quick change on what we did with available calcium, available phosphorus, and how that changed our tissue test. So just wanted you to see that. This is another tissue test. You can look at where the calcium is. It's not anywhere near where it should be. That should be at a 2.0 on the calcium for a tissue test. And phosphorus should be anywhere around that 0.3 to 0.4 on phosphorus. This is a soil test that's going to tell you a little bit more about what's going on in your soils than what you typically would get. And I'm just kind of running through some of this stuff here quickly. Insects, again, are we treating the problem or a symptom? Why are those insects in our fields? That's what we need to be asking ourselves instead of just going out and spraying a insecticide and treating the symptom instead of fixing the problem. This is going to be a slide that kind of tells you a little bit about why you have insects. So that chart up top is a 1 through 20 plus scale. Once you hit that 12 Brix levels, you really start to see less insects, less diseases, and food is now produced for human consumption. So these are just a picture of some dead Japanese beetles in a field in Pennsylvania that we achieved by just raising Brix levels in a soybean field. No insecticide sprayed, and we have some dead bugs there. Okay, so I'm just going to jump kind of into the closing here and just say, what are we going to implement in this land to give our future generations, not a shiny tractor, record yields, not about legacies and trends. It's really about a biologically active soil. Your kids can take over and pass to the next generation. Use the tools that we talked about when you're out in the fields talking to producers, and quit treating symptoms and fix the problem. Please educate yourself and focus on quality, not quantity. Okay, so just going to wrap it up with that. And I guess if we're in the question and answer session, now would be a good time. And I know I jumped through a lot of that last stuff pretty quick, but yeah, so question away.
Donnie, we have one question in the Q&A part here. Maybe we can start with that.
Yep.
How do we know if calcium is available? What forms are available? And how would you increase available calcium? I know you went over that, but it was a while ago. I'd appreciate an update.
Yeah, so available calcium is really not going to be displayed in your soil test. That's just going to be a number. Now, available calcium is where you're going to take a tissue test. You're going to look at what's in that tissue test, and you're going to say, okay, this is what my plant is actually getting, and that's how you can measure it. So when you're looking at available calcium, look at your plant tissue test, sap analysis, whatever it is that you're looking at for the results. That's the best way to see those results and to see what you're changing and how available the calcium is. So hopefully that helps. Anything else?
There was another question while you were speaking about the PLFA and some of those other tests, Donnie. And
Yep.
I just dropped into the chat the Regen Ag Lab piece on that, but all I caught was the PLFA. Were there other tests that you wanted to recommend and talk about?
Yeah, so I'm just going to back up right here to this test right here. So this is from SoilWorks. This is a lab in South Dakota, and they're going to have a lot of the carbon and nitrogen ratios. They're going to have the nitrate and ammoniacal nitrogen tests. So you're not going to only just see, nitrate. You also want to know what the ammoniacal test is too, because that's going to be your reproductive energy seed set. Nitrate, nitrogen is just growth energy. And so that is typically what's on most soil tests. But the recommendation I would give is a PFLA test if you're really looking for bacteria fungus results. And these soil works is also one that I would recommend if you're just wanting more. You want to know more about carbon, like organic carbon, and how your microbial biomass is changing, and then water extractable nutrients. Carbon and nitrogen has base saturations there as well, and it'll give you everything else. But those are two tests that I would recommend for soil tests, and it's going to tell you just a lot more.
There was a question early on about neonics, neonic seed coatings, asking how that impacts soil health. We think about that a lot because at WLA, we think a lot about pollinators, but I would love to hear more about that too, Donnie.
Yeah, so I guess when it comes to seed coatings, I mean, I always feel like if we're treating the soil's life in the soil, the microbiome in the soil, that is where seed treating, I think, has a good fit. I believe that if we're doing insecticidal seed treatments, I feel like a lot of times we're running into some harm. We're killing off some of the beneficials. So on the seed treating side, I guess I have preferences on what kinds of seed treating is going to take place, and what is it being used for. So maybe not like the best answer on that one, other than just be very careful about what you're doing to those living soils.
I'm not seeing any other questions here. Sorry, my phone is ringing, if you can hear that. So
Sure.
Donnie,
Yeah.
what questions should we be asking you?
Yeah. So I guess, when it comes to, I just pulled this slide up because this is a good one to have, right? So growth energy nutrients versus reproductive energy nutrients. If we're just growing hay, or, you know, I guess just grass crops for tonnage, then we want to focus a lot on growth energy nutrients. If we're wanting to set seed, like in a wheat field, or whether it be anything, potatoes, tomatoes, wheat, soybeans, corn, whatever, we want to move to a more reproductive energy part of nutrients. And so, just an example of that is the ammoniacal nitrogen is more reproductive. Nitrate nitrogen is growth energy. And then when it comes to like sulfur, just as another example, thiosulfate is more reproductive energy. Regular sulfate is just your growth energy. And cal-to-mag ratios. I know there's a lot of talk about those being important and not being important, but it's all about balance. And I think those are important numbers. And there's a couple other ratios here to look at, to look for, biology to thrive, or weeds being easier to control. Those are just some numbers that you can take a look at. But yeah, I think really, just one of the things I wanted to drive home is just really educate yourself. And whatever you're doing out in the fields, just make sure that if you have a question, like you're looking it up and not just trusting on an advisor to tell you what to do all the time. Just makes it a lot easier for you to become knowledgeable and become valuable. So, is there anything else?
Yeah, I sure have one. It seems like there's so much that we know about improving and working on soil health and croplands. And it's
Mhm.
such a different thing when we're working in rangeland systems. for, it's like cover crops not being the issue. And there's a lot of discussions going on about interseeding or, what would you do if you've got a lot of crested wheatgrass, a dominance of just one, one grass, and that diversity helps with soil health. What's your advice for those of us who are in rangelands, Donnie?
Yeah, so water's the issue, right? Typically, all the time. And, one deficiency when you go back and look at our talk on deficiencies is, water didn't come up, but water is going to be obviously one of your main limiting factors in that situation. So knowing that you don't have a whole lot of water to deal with, I mean, you're looking and grasping for plants that can thrive in those environments, but there's also diversity that you can find in those environments. I don't know about some of the vetches per se, but I do feel like there's an opportunity there where you can get some diversity and not just grasses, timely before rains, before things like that. And if there's any way that you can water some of those rangelands, obviously you've got more options at that point. But yeah, the grasses, the wheat grasses, we have a lot of those in our pivot corners around here. And a lot of guys do interseed some legumes in there to try to get something else established for some diversity. Not always successful. But again, you're really wanting to build carbon. You're wanting to build soil structure, organic matter. And when you start to do those things and balance it out with calcium, phosphorus, and in a breathable soil, you'd be surprised at how little moisture you need to grow crops that maybe you thought you never could. So hopefully that helps. Okay, well, thanks everybody for your time, and appreciate being able and feel honored to be able to talk in front of everybody. So yeah, just if there's ever any questions, there's my number and my email. Please feel free to get a hold of me anytime and talk through any scenarios, any questions that you might have or might be seeing, and be happy to help.
Donnie, can you see the comments in the chat?
Let me look real quick.
Yeah, there's one right towards the end, Donnie, asking about how to put carbon in.
Yeah,
we're trying to do that. How would you go about it?
yeah. So that's a great question because carbon's a tough one with the environment that we live in. But carbon is one of those where one way we've done it the best and the quickest is by our 7-8 way cover mixes. So when a plant is healthy, it's pulling carbon and it's pushing carbon down into the soil. And when you have a diverse mix of those plants doing all of that in conjunction with different rates of carbon that they're pushing down into the soil, that has been our most effective way to add carbon, is by utilizing those cover crop mixtures. And again, not just an alfalfa grass mix, but 6, 7, 8 way blends, and do an amazing job with all of that. So that's our best way. We've also sprayed molasses and carbon-based products through our pivots, and we see a lot of results with molasses and carbon-based products as well. I'm not here to, I don't want to sell you something specific. I just want you to look towards those resources, and I want you to, do that homework on your own to say, yeah, this is what Donnie was saying. This would work in my situation. And you'll also raise Brix levels quickly in those scenarios as well. So the one field I showed you where the Japanese beetles were dead in that field, that took us 4 years to get to that point. None of this is a quick, easy process. but it's all something that you can make incremental changes and see those changes happen. And once you see it and you have those questions in your mind, kind of like I did at the beginning, you kind of get on fire to figure them out and to answer those questions that you've had for a lot of years. But carbon quickly, the best way has been my experience in this area is with cover crops and balancing soil minerals and making them breathe and available calcium, available phosphorus. Those are all those things are what's helped the most.
There's another question in the chat from Thomas. How about wood chips to add carbon?
Yeah, so I mean, you could go along that line, right? There's biochar, there's wood chips, there's compost, there's all kinds of stuff that you can add to these soils to create that carbon. But, you know, then again, like you could maybe speed that process up a little bit, but let nature do its thing and what it's intended for. And I feel like a lot of times you're going to be very, very successful just by focusing on diverse mixes of covers, diverse plants that are out there is going to probably help you the most. Wood chips will help. Wood chips will help. But, you know, that's small scale. A lot of times, usually on large scale operations, that's a tough thing to do.
There's another question. Where can we get a copy of the Weeds Talk booklet? It's not available on Amazon anymore.
Oh, okay. I will check and I will have to get back to you on that because that's where I got it from. So I will check on that and I'll make sure I find a resource for you to find that book.
Perfect. Any more questions? Any last words, Donnie?
No, just like I say, I mean, the whole point of this is for me is to give you guys some tools and some ways of doing things that maybe aren't traditional, but that have worked in our experiences and that continue to work. And we've been able to lower input costs dramatically in a lot of situations. And I just, want everybody to know to keep educating yourselves and find good information and become self-reliant on what's going on with your soils.
Perfect. Linda put a link in the chat for the Weeds Talk booklet. You can find it there. And then I just want to say thank you very much to Donnie for sharing his wisdom with us. It was way over my head too. But I'm glad that we have people like him that are smarter than me. So, Jim asked if you could put the first 3 books back up. So before you do that, let me talk about these upcoming webinars. So on Thursday, March 12th at noon, we have a webinar called Bringing Water Back to the Land, where we will talk about all the ways to utilize what little water that we're getting. And then on Thursday, April 9th at noon, we will have grazing strategies for drought. And I will have more about those on my website as we get closer. So now go ahead and share your.
What was the question again? She wanted slides.
The first 3 books that you had in your slides, if you can put that slide back up.
Okay, let me see if I can get this here real quick. You said the first 3 slides?
First 3 books.
Oh, first 3 books. Okay. Should be right there, I think. Can you guys see that?
Yep. And we will be sending a recording of this entire webinar out to everyone that was here today, so you can rewatch it to your heart's content.
Yeah, and as questions come up, like I said too, just feel free to give me a call, shoot me an email. Be happy to discuss anything that you might have questions on.
We also had a question, Donnie, if we could share your slides with everyone.
Yeah, yep, no problem.
Okay. Well, we will include those in the email then.
Okay, sounds good.
And
I may have
before-
to send you this updated version of this because I don't know. There was a couple I added, I think. So I'm gonna have to resend you that.
Perfect.
So before we go, we just want to say thank you one more time to the National Fish and Wildlife Foundation who made this possible and are funding Lori's position and her offer of helping people with getting started with management plans. The way the funding works, we have a year to do that. So don't sit on your hands if you're looking at this and thinking that you'd like to do more on nutrient management and soil health. If you're in the Rocky Mountain Front region, that's where Lori can help with this stuff. If you're outside that region, you can always get in touch with Donnie, you cover even outside of the state, don't you, Donnie? Yep. And Western Landowners Alliance, we always have links to people who are doing work in different places. We did a webinar about a year ago on soil health with a producer from New Mexico, another one from South Dakota. And that was primarily on rangelands. But just to reiterate, a lot of the same things that Donnie's saying about cropland, we found out listening to Brett Riley and Dave Alilla to be the case in rangelands in the south and farther east of us. So again, thank you, Donnie. Thank you, Lori and Trina, for the work that you're doing. And thanks most of all to the people who attended here today.
Yeah.
All right. Thanks, everybody. We'll see you in a month.
Okay. Thank you.
Thank y'all.